Thank you all for being here today, and welcome to the 2025 Powering Alabama's Future webinar series, hosted by the Alabama Mobility and Power Research Center at the University of Alabama. My name is Elizabeth Pettit. I serve as the Workforce Development Coordinator at the AMP Center and will be hosting today's episode. Now, whether you are new here or a longtime listener, I would like to start us off by sharing a bit about the webinar series and introduce our lovely panelists. The goal for this series is to provide those interested in the battery manufacturing and electric vehicle industries with a general understanding of various topics such as infrastructure, mining and supply chains, workforce development, safety, economic development, and the like in the great state of Alabama in easily digestible chunks. This episode in particular is titled Raw Materials for the Battery Ecosystem, Mining and Supply Chains. It explores the essential raw materials needed for battery manufacturing and dives into Alabama's role in sourcing these materials and the environmental and economic implications of doing so. Now that my long-winded introduction is done, I would like to take a moment for the panelists to introduce themselves. If you could each share your name, affiliation, and what you or your company do, that would be greatly appreciated. Stacy, let's start with you.
Thanks, Elizabeth. Thanks so much for having us on this podcast today, or this webinar series. My name is Stacy Newstead. I have come from a career actually based in materials engineering and in the defense world. And in the United States, the Department of Defense was the organization that really led the way with understanding critical materials, strategic materials. Now we call them critical minerals, understanding the supply chains that our country was reliant on and where we had certain risks. And as we'll discuss today, for battery materials specifically, we're very reliant on foreign countries, on adversary foreign countries. And so for the last probably 15 years, my career has been focused on critical minerals and options for supply chains. I've been focused on different processing technologies as well as expanding the U.S.'s access to these critical minerals and standing up U.S. operations for processing those materials. Today, I'll be talking to you about Carbonscape. Carbonscape is a New Zealand headquartered company, and they've got their own patented processing technology for turning wood chips into graphite for batteries, and we'll dive into that a little bit later. So I'll be helping Carbonscape on expanding their North American presence. Thanks.
Wonderful. Thank you, Stacy. Let's roll over to you, Scott.
Hey, good morning. My name is Scott Taylor. I'm one of the co-founders and the CEO of Lithos. Company is set up in Bessemer, so just outside of Birmingham. Got a chemical processing facility that we share with a couple other startups. And basically what we're doing is we've got a patented technology that is reliant on electrochemistry. So we're using electricity pulsed through some fancy membranes that are effectively trying to take lithium and potentially other aqueous minerals of some type of economic value from a super salty solution. And so what we're trying to do effectively, here, specifically in North America, there's a lot of, promise to recover lithium from super salty water that comes out of the ground as a byproduct of oil and gas production. So it's a really cool way of trying to create some value from waste. And if you look at where those resources are, there's quite a lot of promise up in the Northeast, in the Marcellus, around like Pennsylvania and Ohio. And then there's a huge, big reservoir called the Smackover that goes all the way from western Florida through Alabama, Mississippi, Arkansas, and it touches a little bit into Texas and Louisiana. And so for what we're focused on right now, just given the economic climate and the political climate, Arkansas is really the first state that's put legal certainty in place. Texas has done so recently as well. So this is kind of where we're down here in the South, just be nearby where the customers are, and it's a great place for us to be set up and do business. Thank you again for having me here today.
Yes, it is so wonderful to have you both. As our listeners can see, you guys have a really big wealth of information and knowledge just about those raw materials, critical materials, and the battery ecosystem in general. So without further ado, we will dive right into our questions. First up for Stacy with Carbonscape, how do you plan to expand production in Alabama?
Yeah, we'll dive right in. I guess we'll start at the beginning. So for batteries, you have multiple chemistries for batteries. The majority of those chemistries require graphite, and a large majority, near 100% of the batteries that are in use today require graphite. You hear about other materials that go into batteries. Some are more expensive per gram than graphite, but in typical battery chemistries, graphite makes 1/3 of the battery by weight, by mass. You can do it either way. 1/3 of the battery is made up of the material graphite. The typical ways that you get graphite is you have natural and synthetic. Natural exists in the ground, is mined, and then further processed to be battery grade graphite. Synthetic graphite is using a byproduct of the oil and gas industry, similar to what Scott explained about what his company is doing. You take petroleum coke and you do a few steps to it. So natural starts from graphite pulled out of the ground. Synthetic starts from petroleum coke, and you do processing steps to make it into battery grade graphite into anode material. There are some sustainability challenges with both practices. There's some financial challenges with both practices. So for petroleum coke, you have fluctuating pricing. So the prices of your feedstock fluctuate, which affect the prices of your end product. For natural graphite, you can't always control where your deposits are and the quality of those deposits. So the higher quality deposits require less money for processing, but they might be located further away, and therefore you're going to incur costs for the transportation or the actual infrastructure to mine the material. So you've got these factors these feedstock factors that affect the cost of the material. For Carbonscape, we start with wood chips. And right now in the U.S., there's abundant supply of wood chips, specifically in the Southeast. There's an abundant supply of wood chips. There's not enough markets for these wood chips, and the prices of the feedstock is consistently low. So now you have Carbonscape saying, well, we're going to make battery grade graphite out of a feedstock that's widely available, very low priced, and very stable priced. And Alabama's forestry industry just really offers a great opportunity for partnership there. The second part about how working with wood chips to make battery grade graphite or graphite anode material that differs from the more traditional methods for natural and synthetic is you process it at a lower temperature. And so cooking something at temperature is using energy. Energy is cost. Energy is what hurts your carbon footprint. So the less energy you can use in your processing, the better your carbon footprint, the better your sustainability report card is. But ultimately, what matters in the real world is the lower your costs are. So Carbonscape's patented processing methods for the wood chips, we use temperatures that are about half of what synthetic and natural graphite processing require. So the idea is we've got a patent process, so IP that's owned by Carbonscape, which we haven't gotten to, what Scott alluded to with the geopolitics going on, but typically for a lot of the graphite processing, all the IP is in China. So Carbonscape brings their own IP for processing it. We bring a low-cost, sustainable feedstock requirements, and the forestry industry is really dying for new markets for their wood chips, so they're very supportive of Carbonscape, and we've got a lower temperature processing, which has better sustainability and results in a high performing, lower cost option.
Wonderful. That was a really great response to that question. I appreciate the background information that you gave, especially for a lot of our younger listeners who may just be looking to gain some general information about the industry and kind of get started or see what options they may have. Carbonscape is definitely very innovative, so we are very excited to have you here today and for you to be sharing more information on that front. Next up, we have a good question here for Scott with Lithos. Scott, how are you collaborating with local businesses and government to expand local sourcing and refining capacity?
Yeah, so I mean, like, we can't really, I'm not really in a position where we're allowed to like promote like the specific customers that we're working with. But I think what, again, I kind of like alluded to this at the beginning, a lot of the target companies that we want to work with are, conventional, pretty boring, like oil and gas producers, typically like oil fields that have been on production for, 50, 60, 70, 80 years. And what we're trying to do is really go out at this point and get the measurements, all, across like multiple different states and try to get a sense of what the fluid chemistry looks like, whether or not there's like an economically viable, like enough enrichment of lithium in particular that makes this economically viable. And so it's kind of like a little bit of a treasure map at this point. There's a sparse sampling. You're going across like 5 different states, and you're just trying to, I'd say, make relationships with the operators or the mineral rights owners that sit across the most attractive parts. And I think that if you look in Alabama in particular, the Smackover Reservoir, intercepts, sort of the southern part of the state, but it's not something that's very prolific. If you look at like from a national standpoint, there's recently been a couple of projects in Arkansas. One that your friend Jesse, who wasn't able to make it today for Standard Lithium, they got approval at the end of May, and that was actually like the first production permit with like a legal framework that had been done in the country in a generation. The only other existing facility is Albemarle has a facility over in Nevada that kind of got grandfathered, and what they're doing is using an evaporation pond, and that's like really the conventional technique. So if you look at down in like Chile, Argentina, and Bolivia to a lesser extent, that's the conventional method, and obviously that's something that would never be permitted here again in the United States. And so what we're trying to do is something that's more like akin to like what an oil and gas facility looks like, where basically you're cycling water at scale through this like effectively a very fancy Brita filter, and you're trying to harvest out minerals that are of value, and strip out the waste salts and then effectively reinject those down into the ground. I mean, there's only like a handful of projects. You've got Albemarle and another company up in North Carolina called Piedmont, and they've got some installed capacity. There's some intermediate capacity that's being done, over in Nevada at the Silver Peak facility. But this couple projects from Exxon and from Standard down in Arkansas will really be the first major installations. And if you look over the summertime, Chevron bought another company that's over in Texas, and so as time clocks forward, you'll see that there's more capacity that's going to be onshore. Much like Stacy said, if you look at like the value chain right now for refining of battery grade lithium that would go into any one of these electric vehicle manufacturers, you've got like probably 75% of the refining capacities in China right now. So it's something that there's a lot of smart people, a lot of great networks and communities like AMP that are trying to collaborate together to onshore that, and that's really the sort of the challenge over the next few years. I'd say from an economic standpoint, we've just gone through what we'll call like a lithium winter. When you have one country that's not particularly friendly what you've seen is a lot of price dumping, and it was done purposely to try to sort of put to stall American, and particularly North American and European investments in new greenfields projects, and also in building up refineries. And so you can see that there's a lot of work left to do. But I think that there's enough of us and enough of a desire to to make a change here that you'll see that there's start to be more local American capacity that comes online.
That is a wonderful response. Being from North Carolina myself, I appreciate you bringing in those projects that are happening a little bit to the north of us. Kind of a follow-up question to that. I know you can't share too much information. What you are doing is very protected. Is there a reason, or what was your process that you guys went through to choose Bessemer as your current location?
Yeah, so we'll probably go back more than 2 years ago. So we had an initial facility that was outside of downtown Denver. It was humble, it wasn't very big, and one of the things that when you're doing this type of rapid development and innovation, we're taking fluid samples from a variety of different locations and then trying to tune our equipment and evidence to ourselves in a very deterministic standpoint with analytical chemistry and measurements that we moved out enough of the waste salts, and we passed through and we've enriched the lithium to a certain grade. So we were faced with a decision that we had to make a couple years ago. One is just we're going to quickly outgrow that facility, and we didn't have an analytical lab set up, and that's not something that's particularly just easy where you snap your fingers and you set it up. It can be quite costly. And so one of our friends that we started the company up with, he had some friends that had done a Department of Energy project where they actually were working for, I think, Alabama Power to try to extract rare earths from the waste stream from coal ash. And so I looked at this report and had a chance to have a phone conversation with these two fellows a couple years ago, and I'm like, wow, these guys are amazing. There's not too many people that have that experience, that skill set. And so we came out and looked at the facility out in Bessemer, and it's enormous, and they had some really good analytical lab set up. And really, what that facility is designed to do is to take stuff from a concept stage where you've got something maybe that's a little setup of some fluid processing, that's processing about like a Coke can worth of fluid, and then try to rapidly scale that up into something that ultimately can go into the field and do some meaningful pilot work. And it just felt like it was cost effective, it was a good group of people, it just made sense also from a geographical standpoint, being closer to where ultimately, if we're successful, we'll be doing this more processing with the end users.
Wonderful. Thank you for that. I'm definitely glad to hear this topic of collaboration kind of throughout both of your just responses, answers in general, because that is definitely something we at the AMP Center try to do, as you mentioned, Scott, just bring together all these different parties and make the end goal happen. So that is wonderful. Before I roll into my closing remarks, do either of you guys have anything final that you would like to share?
I think actually with Scott on the line, we could probably kind of cover two areas that may be of interest to your listening audience. One about the dynamics that have created the market opportunity for non-Chinese suppliers to enter the market, but then the other one that's really about what it's like to be working in these sectors of battery materials. So maybe I can kick off the second part first, but what I think is so interesting about working in this sector that is now termed critical minerals is you have to bring together so many different disciplines. So there's an engineering side to me. I did materials engineering for my undergrad, and you definitely are are speaking to that technical aspect. If you want to get into the different processing technology or extractions technologies, mining, however you get the various materials, you have a chance to exercise that side of your brain. I went on to do an MBA in business because I love understanding what's the business opportunity here. And I think we can kind of talk to the business case for it when we talk a little bit more about the geopolitics that are going on. But there's a whole supply chain aspect. I think one thing that is so interesting in this critical minerals discussion is you have a U.S. government saying we're buying from China, we don't want to be buying from China. And so then you have the commercial world, though. If you're a supplier, you're knocking on the door of your customer going, I know you're getting what you want. I know you're getting it and it's working fine for you and you're getting it for a dirt cheap price, but we'd really like you to consider buying from us instead. And that's a very different business case when there's a lack of supply. And I think sometimes that gets lost in the headlines with critical minerals. There's not a lack of supply. There's a desire to switch who our suppliers are. You will see cases of lack of supply in the news recently. China is restricting their deliveries of rare earth magnets. You'll see different things like export restrictions. There's different trade games being played, and I think that that's really interesting because now you've opened up this whole other discipline, which is national security, and it's it's understanding it. When you read a headline, is this a commercial play or is this a geopolitical play? So having to really understand geopolitics, national security, chemical engineering or materials engineering, mining or oil and gas refining. You get into regulations, right? Why did certain technologies not flourish in the U.S. to begin with before we had all these geopolitical tensions with China? So what I kind of love about this whole sector is you really have to draw upon different disciplines. And then if you take it kind of one level further to batteries, you're talking about batteries, whether you're talking about lithium-ion batteries for your laptop and wanting to ensure that you have functioning, high-performing, secure supply of those batteries, or whether you want to talk about it for your electric vehicle, right? And those conversations are just as dynamic, right? Because some people think you need to electrify vehicles because you want to save the climate, right? But other people could make the argument that electrifying vehicles gives you national security independence on energy independence type thing. So I just find this whole sector draws on so many different disciplines. It's why it keeps me in it, keeps me engaged. They're challenging problems to solve, but I enjoy it.
Yeah, I think for me, like that's the similar sort of perspective that I share. Again, going back for like where we're playing, the conventional at scale industrial process uses these large evaporation ponds, and there's no way that approach will ever be permitted again in North America. So like there's a huge amount of, I'd say, challenge and excitement. It's just fun to be a part of something that's new and it's exciting, and where you've got this opportunity to unlock a lot of value domestically with a new process and the new technologies. But no one's made it work at scale. Like, I keep using, like, look at Exxon and Standard, like they're just doing these, very, I'd say, very, very promising, but small scale pilot projects. And so it's very, it's intellectually stimulating to be a part of like a group of people that are, trying to implement something new at a very large scale, as an industrial process. And that's fun. And I echo the other statements too. It's a space where you get pulled in a variety of different directions. And so if you're interested in analytics and looking at data and trying to learn off of that, there's a huge amount of innovation around just the measurements and trying to use these like fancy mathematical techniques to improve your process. You can be a chemical engineer, you could be a mechanical engineer, you could be a process engineer. So there's a whole lot of like really cool fields, and also like just stuff like that maybe isn't glamorized, but it's equally as important, like being really good at electrician, and being really good person for doing operations and maintenance. Like there's a whole bunch of like really cool jobs that you don't have to have a 8-year degree to to have something where you can use your hands and use your brain and go out and do something very, very positive.
What a wonderful discussion. You both led right into my wheelhouse and kind of my closing question as well. Circling back to the multidisciplinary, collaborative, ever-changing kind of aspect of this industry, I do have one question I'm personally interested in as a workforce development professional. Do either of you have thoughts on how Alabama can ensure the development of a skilled workforce to support these industries? And then what types of training programs might you suggest or have you seen?
Yeah, so I mean, I had the opportunity to come visit with Brad and Mike. I think in December of 2023. Right when we were kind of getting set up down here, and I thought that the entire vision statement around AMP and building a community where you didn't just look at the super high end PhDs, but you actually look through all the different types of vocations and trades that are going to be required to onshore the production of these critical minerals. And I think that one of the things that was particularly compelling was just that this was being thought through, and that the folks that build AMP, they come from the car manufacturing business, and they've got a really good sense around workforce development. Having had a chance to just I'd say participate and watch the program grow, I think it's doing a very, very admirable job. And I think the other thing too that's quite compelling is that this is centered in the University of Alabama, but there's relationships and there's people from Georgia and from Tennessee and from Mississippi, and you've got this little regional hub now that's growing month by month and quarter by quarter. So that's really cool to seeing it go from almost like that building. I was there touring it when it wasn't even turned on, and then the last time I had a chance to come in for the quarterly thing, you can see all these people that are learning and participating, and it's really cool.
So I will build on that. I think I have four aspects that come to mind for me. So as Scott mentioned earlier, training people or having a workforce available for more of the operator level at a facility. So a lot of the pool going on in fundraising and government funding initiatives is saying, we want you to build your processing plant or your plant in the US and in the different states, right? So not only are you standing up a novel technology, but then if you're going to be standing up a processing plant, you've got to staff that plant. So as Scott said, having folks that are operators in the case of some of these materials production is going to be a lot of chemical operators type thing. So that's one. The other one is, I think two are kind of related. So the U.S. is incredibly great at R&D, and in terms of this kind of race with China, we're very strong in our R&D and innovation against China. But when it comes to scaling up and manufacturing at scale, that's perhaps an area where China has put a lot more money and has been a lot more deliberate about becoming dominant in that area. So I think it starts at the university, at the college level, when you study all of these different types of engineering or these sciences, but understanding, can this scale? Can this be economical at scale? And can I source the supply chain for whatever it is I'm making, right? Let's say you design the most exciting new battery chemistry out there, but every material that you require for it comes from an adversary country. Then you've not really made a manufacturable product in the end of the day. And so along the lines, kind of number three, when you're talking about manufacturing at scale, manufacturing in an economical way, AI. I think that when it comes to manufacturing, our competition, in this case China, has embraced AI in the manufacturing facilities a lot more quickly than some of the companies in the US. And, this idea that you have factories that are running dark because your operators are in a control room, not on the floor listening to a whirring sound from a machine. So I think it's just absolutely imperative. I myself fall into that category of like middle age. I'm about to start pecking on my phone if I'm not careful, and all I know is to ask ChatGPT a question. So I'm forcing myself to like really get immersed in it in my personal life, and that came from in my professional life. I was already figuring out how I was going to employ AI in the manufacturing floors. And the thing I didn't realize until a role that I was in for a company a couple years ago is there is a bit of a Great Wall of China of information between the US and China. So when I was trying to really dig deep and research a technical process that we had a tech transfer agreement with a dominant Chinese company in the arena I was working in. I was a bit surprised at how much I could not find online because I am accustomed to being able to dig a lot of information up well. I found a lot of lab level reports to say, well, this is how it works in a theoretical or experimental environment and at a lab scale. And so I think if people can be aware of, if you're trying to leapfrog your competitors, you have to understand what your competitors are doing and the strengths and weaknesses of those competitors. So those are my four ideas.
Wonderful feedback. Stacey, you brought up AI, which can be a whole other discussion, definitely something we are looking at here at the AMP Center and the University of Alabama as a whole. So that is wonderful. And then, Scott, I definitely appreciate your kind remarks about the AMP Center. I know Brad, our consortium development manager, and Mike Oatridge, our executive director, will appreciate those as well. Both of your insights will assist the AMP Center as we move forward with constructing just various training and development programs to ensure the success of these industries within Alabama, which is the ultimate goal, of course. And then this has just been such a wonderful and insightful discussion surrounding raw materials for the battery ecosystem. I wanted to again thank you on behalf of the AMP Center for your continued support. For our listeners out there, please be on the lookout for our upcoming webinar episodes. If you have any questions, please feel free to reach out to me at empitt@ua.edu or the AMP Center at ampcenter@ua.edu. See you next time.